Okay, so 5.2a, basic integration. So we're going to talk about the basics of this thing called integrating, okay? So when you take the integral of something, what you're really doing is you're doing the opposite of differentiation. So you're taking, instead of a derivative, you're doing the opposite of that. So right here, what I wrote is, if f of x is the derivative of a function, then the integral of f of x is that original function plus c. So why would we have that plus c? What does c stand for? C actually stands for constant. So let me remind you of some homework problems that you had a couple weeks ago, let's say, okay? So you had something that was like, oh, here's the derivative. Now think back, what would the integral, or what would the original function be? So it asked you that way. It was like, oh, here's the derivative. What was the original function? So it starts off kind of easy. So on your homework too, it was kind of easy. But you can almost do this in your head. Like, how would you get this as a derivative? You can kind of imagine, oh, well, this used to be an x cubed, I think, because if you take the derivative, the 3 comes forward, and then you have a squared, right, x squared. And then this used to be an x squared, and this was definitely a negative 5x. And then that plus c is because, well, when you take the derivative of a constant, you get a 0. So even if you have a 0 here, when you take the derivative, you get a 0, but you need that plus c to say, well, there could be a constant there, okay? So that's your first little example of like, oh, how would I do this in my head? Let me think. Okay, so here's another one that's like slightly trickier. So what would give you a derivative of sine? Well, I think it's cosine, so I'm going to write that. So cosine x. Okay, is the derivative of cosine sine? No, the derivative of cosine is negative sine. All right, so how about this? Now the derivative of negative cosine would be positive sine. Okay, so that makes sense. Plus, how did I get the 2? Well, when you take the derivative of a number, you just leave it. So here's that. And then e to the x, because the derivative of e to the x is e to the x. And then plus c. Okay, so that wasn't crazy. But then it gets a little bit trickier. So what we're doing today is going to be a little bit trickier, something like this. So we think, okay, first part's not too crazy, but how do you go backwards? Okay, this is why you need to memorize your trig functions for derivatives as well. What would be sine squared for a derivative? Like when you take the derivative of something, you get sine squared, or sorry, secant squared. Well, that would be, you gotta remember it, that would be tangent. So it would be tangent of 3x. When you take the derivative, you get secant squared 3x. But there's a 2 in front, and that's really confusing. So what I'm going to do here is I'm going to put a box. So that's a placeholder, okay? So I'll deal with that later. Don't worry, we'll deal with that later. But then, okay, let's do the next part. Minus, okay, so I can't do this in my head. Okay, maybe some of you can, which is great. But I can't do this in my head very quickly. So instead, I'm going to put another placeholder. And then I'm going to say, oh, this used to be x cubed. Okay, I know that much. Okay, and then plus, there's a 1/3, but then, you know, there's that 2x. Okay, I'm going to have another placeholder. The derivative of e to the 2x is e to the 2x times 2, but then that has to deal with like the number in front, and it deals with my 1/3 and all that stuff. So here's what I know. I have placeholders. Those are going to be some numbers. I'm going to find them eventually when we do our notes. You'll see how. But basically, I just have to realize this came from this. This squared came from x cubed. This came from this. And then the placeholders are what we're going to use to actually find the antiderivatives. Okay? So you'll see what I mean. And then right here, it says integration is the reverse of differentiation. We already talked about that. So it is the opposite. It's the reverse of differentiation. So instead of taking a derivative, you're integrating. Okay, what is integrating? Integrating is when you take the area under the graph between, well, it's not always under, but the area between the graph and the x-axis. So for instance, what we've been doing is we've been finding approximate areas. So we've been doing something like this, but this gives you underestimates and it gives you overestimates. basically it gives you estimates, okay? When you take Riemann sums, even if you're doing trapezoidal, you have estimates, and they're either over or under. However, if you want an actual area, we've been using our calculator. We've been using like Math 9, right? So instead of using our calculator, we can actually do it by hand. So that's what we're doing today. We're doing it by hand, and we're finding the actual area. Okay, so I said the area under the graph, and I was like, oh, not under, it's actually between. So what I mean is, if you have an x-axis here like that, and then you have the graph, so between the graph and the x-axis is going to be some sort of positive area. But you know when you did your homework and you found this area, so if you have a graph that's under the x-axis and then you found the area, you found that it was like negative, right? So I know area is never negative, but integrals can be negative. So these answers actually can be negative. Okay, we're going to give this a try. So for number 1, I know that some of you can do this in your head. I want you to write it in your notes anyway, okay? So here's what we're going to do. So I know that this x squared used to come from an x cubed. I know that x used to come from an x squared. So what I'm going to do is first I'm going to use placeholders. This is my final answer, except for the placeholders. So I know this came from this came from this, a 5 came from a 5x, and then there was a constant, possible constant, so I write plus c. This is my final answer. Now what I'm going to do is I'm going to take this right here, this box x cubed, and then I'm going to ignore everything else, and I'm going to find the derivative. So there's the derivative. I'm going to cover this. The derivative of box x cubed is 3 box x squared, right? I'm going to set that equal to the original term. So when you take the derivative of this, you're supposed to get 6x squared. So I set those equal, and then I divide the x squareds away, I divide the 3, and I get box equals 2. So now I know that in here should be a 2. Okay, even if you can do it in your head, I want you to write that down, all right, for your notes. Okay, for the next part, I want you to do the same thing for this. So over here, I have my 2 box x, because when you take the derivative, you get a 2 in front, and then just an x. You're going to set that equal to the second term, because that was the antiderivative of this. So set it equal to the second term. So when you take the derivative, and then you're going to divide the x's away, and then you find your box equals 4. So now I know that this should be 2, and this should be 4, and then I write it in, and that's my final answer. How can I check my final answer? I take the derivative, and I get this. So if you take the derivative of your answer for integrals, you'll get your, your question, basically. Okay? All right, we're going to do one more, maybe 2 more. We're going to do 2 more together. So something like this, I would start it the same way I start derivatives, aka rewrite it. So I rewrite it as a -3 power, a -2 power, because then it's easier for me to realize, oh, what did I do here? I added 1 to the power to go backwards, right, instead of taking the derivative. So I'm going to do that same thing. I'm going to add 1 to the power, add 1 to the power to go backwards. I know the 7 comes from a 7x, and there's a plus c for my constant. And then I don't know what this number is, okay? So what I'm going to do is I'm going to take this, and I want you to try it now. So you're going to take this, put a little arrow, and you're going to find the derivative of this and set it equal to, you can set it equal to this one, or you can set it equal to this one. It doesn't really matter. But if you set it equal to this one right here, you're going to solve for the box. You're going to take the derivative, you're going to set it equal, and then you're going to solve for the box. So I want you to do that for real and not just copy me. And hopefully you get a -6 and a -4. So I took the derivative, I set it equal, I took the derivative of this, and then I set it equal to that. And then I got my box. So I divided all the x's away, and then I divided the negative, right? Okay, so now this is my final answer, but I just fill in my box. That's it. See how it's the same thing? The -6 goes here, here's my x squared. The -4 goes here, here's my x to the -1, here's my 7x, and my c plus c, okay? Okay, So I want you now to try, don't fake it, don't copy me, try number 3. So you try it, you write it down, and you're going to get stuck, but I want you to write it down. And then I'll show you why you get stuck. So you have this, right? So you change it into a negative exponent, and then you get this. And then you think for a second and you realize, hopefully, that doesn't make sense. Because x to the 0 power is 1, and if you have a number times 1, that's a constant, and the derivative of a constant is 0. So, that doesn't work. I want you to write it down. I want you to have like question marks and stuff. And then I want you to remember, how do you get a 1 over x as a derivative? Oh, that's when you take the derivative of ln x. So this used to be actually an ln x. And then you need that absolute value because I don't actually know what x is. X could be positive, but when you take the natural log or any log, you need to take a log of a positive number, right? So the part of the definition of a log is it has to be positive. So then you have box and then this plus c. That's going to be your final answer. You're looking for the box. Take the derivative of this. Solve for the box. Do it. And then hopefully you get 3. And then how can you check this? You find the derivative and then you'll get that. Okay? Okay. So for the next one, I'm not going to finish it. I'm going to show you the first step, but I'm not going to finish it. So something like this. This is a power rule. And so far, we're not going to do power rules, okay? So if we can make it easier, as in multiplying it out, then we're going to multiply it out, and then we're going to find the derivative, or the antiderivative, okay? So from here, I want you to do the box method. I want to see the box method. And then I'm going to ask you for your answer. Actually, when I see you again, I'm going to ask you for your answer. I'm going to randomly call on you. So if you give me the right answer, you get a plus 10. If you give me the wrong answer, that's totally okay. I'm cool with the wrong answer, okay? But if you say you don't know, or if you say, Miss Tan, I didn't do it, then, or Miss Tan, I need more time, then no, you're going to get a minus 10. So let me repeat that. If you give me the right answer for number 4, then you're going to get a plus 10. If you give me the wrong answer, that's totally okay. But if you say you didn't do it or you need more time on number 4, then you'll get a minus 10 automatically in your bin. All right, that's how mean I am. Okay, so number 5. Where's number 5? Number 5, same kind of thing. I'm going to show you the first step. The first step is to change it into 2 fractions, right? Because it has the same denominator. So change it into 2 fractions, reduce, and then find your antiderivative. You can do it. So I want you to try this. I'm going to do the same thing as number 4. Give me the right answer for plus 10. Give me the wrong answer for that's totally okay, but don't give me an answer and then you have a minus 10 right away. Okay? I really am that mean. Okay. So on the back, same thing. So on the back, how would you start this? I would do the same thing as number 4 and 5 basically. So in number 4, you multiplied it out first, and in number 5, you made fractions. So you're going to multiply it out, right? When you multiply, you get x squared minus 1, and then you're going to make 2 fractions, and then you're going to find the antiderivative. And then right answer, 10 points. Wrong answer, that's cool, no problem. But then no answer is major problem. Okay, so here is the last part. So this one, I'm going to show you the first part. Show you an example of it, and then we'll do them together. So finding a definite integral. So what we did was we found integrals, but this is a definite integral. Like this is when you're actually finding, you know, values, okay? So the definite integral is going to be literally the area. So we're saying this represents the area under x squared between 0 and 3. So the area under x squared, well, between x squared and the x-axis, between 0 and 3, okay? So that's what this represents. So once it has numbers here, then that means you're finding a definite integral. So how would you do that? So the first thing you would do is you would find the antiderivative. So that's the antiderivative. That's what we did on the other page. So that came from an x cubed. That must be a 1/3. Otherwise, when you take the derivative, you wouldn't get a 1 in front, right? So you get 1/3 x cubed plus c. And then right here, I do a little, it looks like a bracket. And then I say 0 and 3. So I copy my 0 and my 3. And then what you do is you plug in the 3, and then you minus, and then you plug in the 0. So here's my work for it. So see how this is the same thing, but I plugged in the 3. And then this is the same thing, but I plugged in the 0. And then you'll notice what always happens when you're finding definite integrals is when you have your plus c, the c's are going to subtract away. So the constants are going to subtract away, all right? So what we really care about are these parts. So then you just, keep working on the numbers. So this gives you 9. This gives you 0. 9 minus nothing, so just 9. So the area, if you put this into a calculator, between 0 and 3 of x squared is 9. Okay, so we're going to try it together. So you're going to find, I'll do this one with you. You're going to find the area between 0 and 2 of this parabola. So the first thing is, you're going to find I think you can do this one in your head maybe. Find the antiderivative of that, which is x cubed plus 2x squared minus 2x plus c, right? So find the antiderivative. If you need to use boxes, it's fine. And then you're going from 0 to 2. So we write it like this, 0 to 2. Now you're going to plug in 2, plug in 2, plug in 2, minus, plug in 0, plug in 0, plug in 0. Actually write it out. So plug in 2, plug in 2, plug in 2, plus c, minus, plug it in, and then you get your final answer. So that's going to be a 12. If you put this into a calculator, it would say 12 exactly. All right? Okay, so your homework is actually going to be worksheet 22, which is on the right side. So you have 1 through 16. The answers for 1 through 16 are here. I have these little slashes, okay? So you're actually going to do part A and part B. So for 1 through 11, I would say, see how 1 through 11 has those slashes? You're actually going to do definite integrals. So for 1 through 11, I'm adding on to the problem. You're going to go from 1 to 2, from 0 to 3. So kind of like right here, how it goes from 0 to 2. So for number 1, you're going to go from 1 to 2. Like you're going to pretend there's a little 1 there and a little 2 there of this. Okay, so you're going to find a definite integral for 1 through 11. So for the answers for 1 through 11, these are the integrals, but then when you plug in, you should get this at the end. You should get those at the end. All right, so give that a try. And then number 16, the answer is going to be right here. All right, so if you, oh, and then right here, like I just did it one more time, how to find the definite integral, but we already did it in our notes, so we're fine. All right, so you're going to do part A and B. So you're going to use up all of these answers. You're going to find all these answers. All right, you can do it, you can do it, you can do it. Make sure that when I ask you about number 4, 5, and 6, you have answers ready. Even if it's the wrong answer, that's totally fine, but you should have answers ready, okay?